We know that the Unix shell can be thought of as a programming language. In this chapter, we start examining some of the simple features that make the shell an actual programming language. In other words, rather than just learning a series of simple shell commands, we will be delving into the actual programming features of the shell. Also, at the end of this chapter, I will introduce you to the course project. That is a project that we will be developing for the remainder of this course. Let's begin now with shell variables. We've already been introduced to variables just briefly when we were using the read command. At this point, I want to go into variables in more depth and more detail. So what is a variable? Well, if you're a programmer, if you've programmed in any other programming language, you probably already have a fairly good idea of what a variable is. For the rest of you, I will take a few seconds to explain this to you. Firstly, the technical definition is that a variable is a small, named piece of memory that can be assigned a value. An example of a variable might be the variable called month, which I am here in this example assigning a value of August to, using the equal sign. We say that the variable called month contains the value of August, and these values can change, which means of course that I could assign another value to month. I could say, well, instead of assigning August to month, I could now assign July to month. One way that I like to think about variables, and one way that I like to explain to people that don't know what they are, is that a variable can be thought of as a little box, and you can put things in the box. The box might actually have a label on the front of the box. So if we relate that back to our month example, we have a little box that represents the variable month. The box has a label on the front of it. The label is month, and we put things into the box. We put August into the box in this particular example. And if we ever decide to put a different value into the box, like July, then whatever was in the box before is lost, erased from memory, if you like. The name of the variable that you can see on your screen is month. Let's now be very particular about the sorts of names that variables can have. Let's look at a list of rules regarding variable names. Firstly, variable names must be unique. That means that no two variables can share the same name. The name of a variable can only be comprised of the following characters: the lowercase letters, the uppercase letters, digits, and the underscore character. No other characters are permitted to be used in the name of a variable. As far as the contents are concerned, that's a completely different story. You can put just about anything into the box, if you like, but the label on the front of the box must be made of just the following characters. Furthermore, the name must not begin with a digit. It can begin with a letter, or it can begin with the underscore. Also, these names are case sensitive. If you create a variable called month, all in lowercase, and then you create a separate variable with a capital M for month, you have actually created two different variables. Moving right along, I'll take a quick note here, and for the experienced programmers amongst you, the people that have already programmed in other languages before, it's interesting to note that all shell variables are strings. If you don't know what a string is, it doesn't matter at this point. The point to note here is that there are no integers, no numbers in shell variables. You can certainly assign a value of 5, say, to a variable, but that 5 will be treated as the string 5, not the number 5. What this means, of course, is that you cannot do addition using shell programming. Addition, subtraction, multiplication, division, they are not built in to the shell language because all shell variables are strings, not numbers. However, it is possible to do addition and subtraction in a shell script, but you have to use an extra utility program called EXPR, which we will look at later on in this course. And now, for everybody again, values may be assigned to a variable using the equal sign. An example of that is sport equals basketball. We are assigning the value basketball to the variable called sport. Now please note that there must be no spaces on either side of the equal sign. This is different to most programming language, but you simply cannot have spaces around the equal sign. If you do, you will not get the results that you are hoping for. Furthermore, if you need to assign a value to a variable and that value contains spaces, then you have to surround the value with double quotes. For example, if you wanted to assign Smith Avenue to street, and Smith Avenue is two words with a space in it, then you have to put double quotes around the whole lot. As an exercise right now, why don't you try and do that without the double quotes and see what error messages the shell gives you. Now, so far we've only looked at how to assign a value to a variable. Now, the whole point of variables is that you are then able to retrieve the value in the variable at any given point in the future. So of course I have to show you how to do that. To retrieve the contents of a variable, in other words to get the value out of the box or to know what is in the box, you use the $sign as a prefix before the variable name, like so. Here, using the street example just prior, we can say you live on, and then we put a $sign, and then we put the name of a variable. Now if Smith Avenue was in the box called street, then what we would see on the screen would be you live on Smith Avenue. Now I'll just give you a brief demonstration of all of that. So we'll use one of those examples that I mentioned before. I can say sport equals basketball, and I don't get any messages on the screen. It's just simply an assignment statement. I'll show you what happens if I try and put spaces around the equal sign. Sport equals basketball. It actually treats the word sport as the name of a command to run, and we don't want that. Anyway, now I will examine the contents of the variable called sport by doing that, and it simply echoes out basketball to the screen. Notice that the $sign is very important. If I just do that and say, well, show me the contents of the sport variable, I actually just get the word sport, which is probably what you'd expect if you thought about it. The $sign is needed to say, don't just print out the word sport, print out or treat the word sport as the name of a variable and give me the contents of that variable. So you can also do things like this. I like to play $sport gives, of course, I like to play basketball. Then also the sport variable can be assigned to something else. I'll try doing this. Now this is going to give me an error, and let's look at what the error is. Polo command not found. Now why would that be? And the answer is because I didn't put quotes around the not water polo. Now that does not give me an error anymore, and I can say echo $sport, and of course it is now water polo. Okay, well that's a brief introduction to variables. Let's move on and now talk about environment variables. When you run a given script, you will find, if you look, that you actually have several variables that have been set for you already. This collection of variables that are preset are known as your environment. You can think of these variables as being inherited from the login shell. In other words, you'll find these same variables have been set in the login shell and simply inherited into any script that login shell starts. I'll show you some examples of those variables. They include the variable called home in capitals. These are all case sensitive, so the fact that they're capitals is significant. Path is another one. Log name and term, and they represent in turn your home directory, a list of directories in which to search for command names, the person who's currently logged in to this particular shell session, and the terminal type that you're currently using. In other words, all of that information is available to you in your shell script. Usually. There's no guarantee that any of those variables is going to be set in a given shell script, but usually you'll find that most of them are. Whether they are or whether they're not is not really important to this particular module. The point is that there exists a collection of some preset environment variables. And let's look at what that means to us. Firstly, it's very important to note that you can actually make changes to any of these variables in a shell script. But the changes that you make will only have a duration of the length of the script. In other words, when the script finishes, the changes that you've made will disappear. The login shell that caused these environment variables to exist, as well as any subsequent shell scripts that you call using that script, will see the original values of those variables, not the changed values. Now, if you think back to the previous chapter, you'll remember that it is actually possible for any changes that you make to an environment variable to persist when you run a shell script, but you have to invoke the shell script using the dot operator. Remember the old dot space dot profile? Let me show you an example of what I'm talking about. Here is a small shell script called test1 that I've just written, which sets the variable called home to be some garbage value xyz. Now let's first examine the real variable called home, which is set to /home1/mvirtue. And now what I'll do is I'll run the script. I haven't bothered to make it executable. sh test1, and it runs, so it's obviously changed the value of home to be xyz. So let's now look at the value of home again, and it has not actually changed. Let's go back into test1 and prove that it did actually change it, and do an echo of $home here. So notice that we're actually echoing out home at this point, and we'll run test1 again, and it does in fact change it to xyz, but when we examine home again, we still find that it has not been changed at all. The only way that we're ever going to successfully change the value of home using that script is if we use the dot variable. Instead of running test1 using sh, we run test1 using dot. And so we do it like this. And again it claims that it's changed it to xyz. And now let's see if it indeed has. Echo $home. And this time it really is xyz. Let's now take a word about creating new variables and adding them to the existing environment, which is possible to do. If you create a new variable, that variable will not be available or visible to other programs, including any other shell scripts that you may write, unless you add that variable to the environment. Now there's a very particular way of doing that. You add it to the environment using the export command as follows. You can say month equals January or any value like that, and then you simply say export month. Now what happens at that point is the variable called month is added to the environment, and what that means is that any subsequent program that is started by this particular shell will know of the existence of the variable called month. Now let me tell you what that does not mean. If you put those two lines into a shell script and you run that shell script in the normal way, not using the dot operator, the variable called month will be added to the environment of the shell script that is running, but it will not be added to the login shell environment, which means that any subsequent shell scripts that you run will not know of the existence of the month variable. If you want to add the month variable to the environment of the login shell, you actually have to run those two lines. You have to enter those two lines into the login shell's prompt. Or, if they are in a script, you have to run that script using the dot operator, which will cause any statements in that script, of course, remember, to be executed by that login shell, which will mean, of course, that the month variable will be added to the environment of that login shell. I know this is very confusing, but let's have a look at an example. Hopefully that will make things clearer. So here's a very small script that sets the value of month to July and then adds it to the environment of whatever shell happens to be running this code. So let's run this. I'll just do an sh of set month. Okay, now theoretically that's been added to the environment, so let's look at what month is set to. Echo $month. It's not set to anything because it has only been added to the environment of the shell script that just ran. It has not been added to this login shells environment. And I've got another program called test month. I'll just show you what that looks like. In test month I've simply got a line of code that says echo $month, and if I run test month it does not know anything about the value in month. So if I actually want to be set and added to the environment, and I want to do that using the setMonth script, then I have to run the setMonth script using the dot operator, like so. Now I can do echo $month, and I find that's actually set to July. And if I run any other script like test month, which is got to be run this way, test month, it's also knows it now to be set to July. So the importance of the environment is significant. If you add a variable to the environment of a given shell, then that variable will be available to any script that is run from that shell onwards. And remember, of course, that that has all been done using the export command. The trouble with quotes. If there's one topic in Unix shell programming that gives more confusion and more anxiety to shell programmers, it's the use of the various different types of quotes. Hopefully in this module I will clarify the use of quotes for you, and this confusion will not be severe as for you as it would have been if I hadn't explained it to you. You'll still have trouble with quotes. I have trouble with quotes. Everybody has trouble with quotes. But hopefully you'll have, well, less than most. Let's begin and have a look at what we're talking about here. In Unix shell scripting there are 3 different types of quotes available. Each of these types of quotes is used to surround a piece of text. In other words, you put one quote at the beginning and one quote at the end, and then that text in the middle is said to be quoted. And you always put the same quote at the beginning as you put at the end. There are 3 different types of quotes to choose from. Let's have a look at them. The first is single quotes, which are sometimes known as apostrophes, and you can see the character on the screen there that I'm referring to. We might call it the quote character. So you can put one of those at the beginning of a piece of text and another one at the end of the piece of text, and that text is then said to be quoted within single quotes. Then we've got the double quotes, or the rabbit ears, or quotation marks, or call them what you will, which can also be used to surround a piece of text. And then of course we have what we call the back quote, which is like a single quote except it kind of faces the other way. And if you need to locate the backwards quote on your keyboard, you will probably find it underneath the escape key on the same key as the tilde character, the squiggle character. Now of course on some Unix terminals it could be anywhere, so you'll just have to hunt for it. And as I mentioned before, as a shell programmer, sorting out the various nuances of these 3 different types of quotes will bring you many wonderful hours of frustration and bug chasing. If I had $1 for every time I have gotten the number of quotes wrong. But that's all ahead of us. Let's proceed. We'll begin with single quotes. Let's see what single quotes are for. Remember that I spoke to you earlier about special characters used by the shell, and there's a bunch of them, such as the $sign, the brackets, the asterisk, the hash or the pound sign, and also including things like the space character. So here's how that has to do with single quotes. If you take a piece of text from a shell script and surround it by single quotes, then every character between the quotes is now considered to be a normal non-special character. In other words, all the special characters lose their meanings, including spaces. The only exception to that rule is another quote. Well, another single quote, that is. And the reason for that is the parser that's reading over the script has to know where the set of single quotes ends. If you're wondering what the special meaning of the space character is, it's used to determine that a parameter to a command finishes and the next parameter begins. In other words, it separates parameters from each other. Every parameter to a command is separated from the next one by a space. Now, if you put quotes around that, then it is now no longer treated as a special character. So two parameters become one, and so on. So this includes spaces. It even includes new line characters. A new line character in the shell means, okay, I've entered one command, now run that command and present me with another prompt. So if you put quotes around the new line, in other words, you put one quote at the end of a line or somewhere on one line, and then you put a new line, and then somewhere on the second line you put the closing quote. So the new line, the enter key that you hit is somewhere between the quotes, then that new line will not be considered to be the end of the command. The actual command will finish after the second single quote. I think I should probably show you an example of what I'm talking about. I'll just do that quickly. So here's the example, echo and then single quote. Here is some, and then I'll press enter. And now look, I get a little angle bracket, which is sort of a second prompt. It's not my original prompt, but it is a prompt of some description. And I'll type in text on several lines. And let's see what we get. And we actually get it echoed out on 3 separate lines. So that is indeed possible to do that. So another example is echo the total is nearly $750, and will cause that output to appear on the screen, just as you would expect. Now, there is something interesting about that. Notice that the $sign, the second one, the one next to the $750, the $sign is considered to be a special character. But when you put it inside single quotes, it loses its special meaning and is just then treated as a normal $sign. So, that's the use of single quotes. Now let's have a look at double quotes. So when you think you've got your head around all that, double quotes come along and mess up the picture a bit. Now I mentioned that single quotes actually remove all of the shell's special character features. Now this is okay, but sometimes it's a little excessive. As a convenient shorthand, we may actually prefer some of those special characters to work. And the ones that I'm talking about are using the $sign for variable substitution. So we may like the $sign to remain special. And the backwards quotes, we may like that to remain special as well, and we'll explain about the backwards quotes in the next section. And also certain constructs may be very useful to us as well, like using the backward slash character to render certain other characters non-special. I know this is very confusing, so we're going to have to look at an example. If we surround the given text with double quotes instead of single quotes, then the above 3 different types of features will still remain special, while the other characters will be non-special. So that's actually a typo on the screen in front of you. That should be the other characters are still treated as non-special. Let's look at that example. Now this is a somewhat complex example, so let's go through it character by character. Notice that the text is completely surrounded by double quotes. And then we've got a variable called logname, which is obviously prefixed by a $sign. Now, is logname going to be substituted for the actual variable contents? And the answer is yes, it will, because the $sign remains special inside double quotes. So if the $sign remains special, then some strange behavior is going to happen when we try and print out $1,000. So we actually put a backslash in front of the $sign to get the $sign to be non-special just for that one instance. And then some other text enclosed in back quotes, that date plus %b, and I'm not going to explain to you just at this point what enclosing text within back quotes does, but suffice it to say that whatever it does, it's going to continue to do it because back quotes remain special when they're inside double quotes. Then of course we have the closing double quote right on the end of the line. Now that will then give us Peter, well let's assume Peter is the current login name, So that the log name will be substituted there, so we'll get Peter made $1,000. The dollar sign comes out beautifully there because we put a backslash in front, and the date actually gives us November if we happen to be doing this in the month of November. So it is somewhat complex, the use of double quotes. So let's compare and contrast single quotes with double quotes. They are almost exactly the same, except for the use of the dollar sign and the use of the back quotes inside the double quotes or inside the single quotes, as the case may be. So when would you typically use one and when would you typically use the other? Well, I have a personal rule that I use in this particular situation. I usually put things inside double quotes because it gives me the convenience of substituting variables and using back quotes. And the only time I use single quotes is when it's absolutely necessary to, when I absolutely want to guarantee that not a single character inside the single quotes is special. And there are very specific instances where that is useful, such as passing special search parameters to grep or find or something like that. So maybe as a rule of thumb, keep everything inside double quotes unless it doesn't work, and then perhaps put it in single quotes and see if that fixes anything. So let's move on and look at back quotes. Back quotes actually have got nothing to do with special characters. They are not really related to single quotes and double quotes. Single quotes and double quotes are related to each other, but they're not related to back quotes. So this is what back quotes do. If you put some text inside backward quotes on a command line, that is treated as its own individual Unix command. Everything between the quotes is treated as a separate command and is executed in its own shell. And any output that is generated is substituted into the script line, replacing what was inside the back quoted. Now that sounds awfully complicated, and it is somewhat complicated. It does take a bit of getting used to. You might recall that example from the date that I showed you. Well, let's have a look at some more examples. Now you do this, enclose who pipe to sort inside backward quotes. Then what would happen is the who program would run and the output would be sent to the sort program for sorting, and then the output of that would get stored in the variable called list. It's very handy to be able to do this occasionally, to take the output of a given program and assign it to a variable. Then, if I were to echo out that variable, I would get the following. Fred is on 2 and he's on from the particular date. Then Peter's on TTY01 on a different date, and Tony's on TTY05 on another date as well, which is almost exactly what you'd expect, except all the new lines have disappeared. So any text that is generated from a command inside backward quotes has all of the new lines removed, or at least turned into spaces, and all of the multiple spaces and multiple tabs are all resolved into a single space. There are very good reasons for it doing that, and you can think of that as a particular nuance or feature of output generated by commands inside backwards quotes. Let's look at some more examples of the back quotes, because it does take a little bit of getting used to. So here's an example. Echo, and then the thing that I want to echo is the date is something today. Now that something is the result of the date command. So basically take the date command, and I want the date to be in a particular format, MDY, Y. So I want the date command to generate some particular output, and then I want that particular output inserted on that line in place of all the stuff inside the back quotes. So let's see what we get. We get the date is 08/22/01 today. If I ran that again, but this time without the arguments to date, then it would simply say the date is Wednesday, August 27th, 1638:42 EST 2001 today. Or I could be a little bit crazier and have nothing to do with dates. I could just mix it up a bit, and I could say ls, or any Unix program could be put there. The date is chapter 2, chapter 4, contacts, log files, blah 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 blah, which of course has nothing to do with today's date, but it is the result of a particular command. Notice that it all appears on one line, simply separated by spaces. So of course things you can do there are myfiles equals back quotes ls, back quotes. Now the ls program has run, but the output from the ls program has, instead of going to the screen, has been assigned to the variable called myfiles. So then of course I could, at any time I could say echo $myfiles, and then I get a list of all the files in this directory. So I hope that will be a good demonstration of the use of the backwards quotes. We're going to use that considerably throughout the remainder of this course. And of course we're probably going to use the single quotes and double quotes even more. So it's vitally important that we have a good grasp of the difference between all of these three things. I would, if I were you, probably go back and review this particular module now to make sure it's very clear in your mind, because it will trip you up in the future, I promise you. Occasionally we find it necessary to group several commands together and treat them as one command. Now, why might we want to do this? Well, consider first the various actions that may be applied to any given single Unix command. You might want to run that command in the background, using perhaps the ampersand sign. Or you might want to redirect the output of that command to a file or to another program using the greater than sign or the pipe symbol, and whatever else. There's a bunch of others. Now, if you wanted to actually apply one of those actions, such as running in the background or redirecting, to several consecutive programs, what you actually might want to consider doing is group the programs together and then apply that action to the group. Let me show you an example of that. Suppose I had the following two programs. One is the echo program, just echoing out the words "the date is," and the second program is simply the date program, and I wanted the output from both of those programs to go to one file, called in this particular case output file. Then what I can do is enclose those two Unix commands inside round brackets or parentheses, and then that whole thing from the first open parentheses to the last closed parentheses can be considered to be a single command. And then of course you can do with that what you will. You can redirect the output somewhere else, or you can run that asynchronously in the background, or whatever. And you can put as many commands as you like inside the round brackets, and the same action will be applied to every single command. And I'll show you another example of that. I can simply type an open bracket on a line by itself, press enter, and the shell says, oh okay, well you're going to be grouping some commands, so here's a little secondary prompt to go on with that'll let you know that you're still in the grouping phase. So I can say, alright, pwd followed by an ls followed by anything, it doesn't really matter who, and then I will close the round brackets there and run all of that in the background. So let's have a look at that, press enter, and well, it's difficult to actually determine that it did run in the background, but I promise you that it did. Notice that I do not get my shell prompt back. Well, I did actually get a shell prompt back, but it's now scrolled way off the screen, so I can no longer see it anymore. But if I press enter, I'll get another shell prompt showing me that that command is now done. Brackets pwd ls and who, close brackets. So there's a handy little feature that you can take advantage of if you need to in shell programming, and the need does come up occasionally. It's good to know that it's there. Finally, in this chapter we have two shell features that I'd like to show you, both of which pertain to line control. The first of them is that it's actually possible to run two or more Unix commands on the same line in a shell script. In other words, you could run a who command and an ls command on the same line before you press enter, as long as you separate the commands with a semicolon. Let's have a look at an example of that. This is actually a tricky little example, so I'd look at it closely if I were you. We've got two commands here, all on the same line. The first is the echo command. We're echoing out the text, please enter your name, colon. Notice that the colon is part of the echo command. It's just simply one of the characters that we're going to echo out to the screen. Then we have a semicolon which says to the shell, right, that's the end of one command. Everything else on this line is actually another command, and the other command is, of course, read name. So let's have a look at that in action. Give you a simple example first. I'll just do a PWD, then a semicolon, and then an LS, and of course you get the two commands running like that. You get the current directory followed by the contents of the current directory. And now I'll show you that other example. Echo, please enter your name, colon, semicolon, and then read name. And it says please enter your name, and then I can obviously type in my name, and then it completes. And then just to prove that it actually did work, echo out $name, and I get Mark, of course. So that's a handy little thing to be able to do from time to time. Let's have a look at the second line control option. Occasionally, for aesthetic reasons, you may wish to split a command line over more than one line of text. Now this is actually not too difficult to do. You've actually seen a couple of ways of doing it already by surrounding the text with single or double quotes, but occasionally you want to do it when there is actually no appropriate use of quotes at all. So in that case you can use the backslash character. And an example of that might be, this command is split, and then as the very, very last character on the line, it has to be the last character on the line, you can say you can put a backslash character, which will make the next character, which in this case would be the new line character, non-special. In other words, you'll still get the new line in your echoed output, but the new line is no longer considered to be the end of the command, which is what new lines are usually treated as. The command will actually end at the second new line, which will be after the word lines. So keep that in mind when you're writing shell scripts. Occasionally you write great big long command lines and you don't want the text in the editor to automatically wrap, so you can actually wrap it yourself by putting a backslash on the end of the line. Okay, well that's the end of the actual content for this chapter. We'll now get on and have a look at some exercises for this chapter, and then we'll have a look at the course program. Here are the exercises for chapter 4. The first exercise is to determine which of these variable names that I'm going to put up on the screen are actually valid variable names and which of them will give you error messages. The first one is the variable called month. The second one is a variable called echo, then $year, 24_hours, hours-24, 50%, first space name, just the letter A, _first_name, and winner exclamation mark. You might want to just pause the video here and write down those various ones and maybe put a tick next to the ones that are valid. We'll go through the solutions presently. If you get confused, you might like to simply type them in to a Unix terminal and see what you get. Okay, next exercise. Create variables that contain the following values. Just create a variable that contains the value Fred. Create another variable that contains Fred Smith, and create a third variable that contains the text "That's life." Now we've got to prove that that actually worked, so echo those variables out to the screen so that you know that you got it right. Next exercise. Set a variable called age to 45, and do that not in a script but on the command line. Then write yourself a very brief script to echo that value out to the screen. Now there's a little secret step somewhere in there that you have to do in order to make that work, and I'll see if you can figure that out by yourself. Next, what's wrong with the following code? You might want to pause the video here, stare at it for a while. If you can't figure out what's wrong with it, you might want to copy it down and type it into a script or into the command line and see if you can't correct it. Finally, cause all of the following output to be sent to one single instance of the more program. Today's date, current directory name, contents of the current directory, list of users logged in, all of that should go to one instance of more. And see if you can't do it on a single line of code. Okay, those are the exercises. Good luck. Start the next movie when you have got the answers, or when you feel that you can no longer make any sensible attempts at the answers, and I'll go through them with you and explain. Here are the solutions to the exercises from Chapter 4. How did you go? Okay, well, I'll go through them with you. Let's do the variable names exercise first. Which of the following are valid variable names? Well, month was perfectly valid. Interestingly, so was echo. It is perfectly okay to have a variable name that is the same as a Unix command. Now, this was not valid because if you put the $sign in there, that refers to the contents of the variable to be displayed, or variable substitution. It is not a variable name. Next, 24 hours is not valid because variable names cannot start with a digit. And similarly, this one is invalid because variable names cannot contain a dash. An underscore is okay, but a dash is not okay. A %sign is right out. Also, you cannot have a space in a variable name. You can certainly have a space in a variable's contents, but you can't have a space in the variable's name. Just the letter A by itself is a valid variable name. Variables can be just one digit if necessary. One character. Can't be a digit. It can't be a digit because variables cannot start with a digit. They can have digits in them, but not at the beginning. Underscore first underscore name is perfectly valid. It starts with an underscore, and that is okay. The only thing it can't start with is a digit. And winner exclamation mark is not valid because variable names cannot contain exclamation marks. Now I'll show you some solutions to the other exercises. Here is a small script called variables, which I have written to solve the question on creating variables that contain certain values. This script is available on the course CD in the Chapter 4 folder, and all the other scripts that I show you are also available on the CD in the appropriate place as well. So let's go through it. We've got the first one, which is simply name1. I've called my variable name1. I can call it anything I like. It just simply contains Fred. Name1 equals Fred. And then I echo it back out using the $sign in front of name1. Now name2 was almost the same as that, except I had to enclose the Fred Smith in some kind of quotes. Now, which type of quotes could I use? Well, I could use single quotes, which I have used here, or I could have used double quotes as well. Either one would have worked perfectly fine. The reason I had to enclose it in quotes is because there is a space in the variable's value, and there's no way I'm going to be able to assign a value with a space in it to a variable unless I surround that value with quotes. And finally, the that's life. Well, I can't possibly surround that with single quotes because the actual text itself has got a single quote in it. So I actually have to surround it with double quotes, which makes everything work. Okay, let's just prove that that worked. Colon, exclamation mark, %. Remember my little shortcut, the %sign. And Fred Smith, and that's life. And that worked. Now we'll try that second exercise on setting the age. So I simply do this, age equals 45. Then I run the script. I've got a script which I'll show you. It's called simply age script, and that's available in the CD as well, and it just simply does an echo $age. So let's run that, age script, and it echoes nothing at all. Now why is that? What's the magic step that I still have to do here? Can you remember? Well, that's right, I have to export age. I have to make the age variable available to all subsequent scripts. So I do that. Age is now exported, so if I run age script again. This time I get 45. So that's a little exercise on the virtues of exporting your variables. You don't have to export a variable, but you do have to export a variable if you plan to have it used by another script. Finally, here is the exercise on the Joe script. Now here is the code that's simply copied directly from the exercise, and this of course will not work. Let's just prove that it will not work, and yep, I get a bunch of error messages. Okay. So what in fact is wrong with this? Well, the first thing is we've got this little usage of the date program here. We're obviously trying to cause the date program to run, so we need back quotes for that, so I'll change those into backward quotes. But notice of course that the backward quotes are now inside single quotes. There's a single quote there, and then right at the beginning before the word hello there's another single quote, and if we want the backward quotes to be special and for this all to work, we can't enclose them in single quotes because nothing is special inside a single quote. So we've got to turn this into double quotes, and again we've got to turn this one into double quotes as well. Alright, so let's save that and try and run that. Hello Joe, today's date is, and then there's today's date. Now, the fact that it was on multiple lines is perfectly okay. We've got the echo starting on this line and finishing on that line. That's fine. And the fact that there is a single quote right here, that's okay as well, because that single quote is inside double quotes. And when single quotes are inside double quotes, they are no longer special. So that is a working version of the script. The script is now corrected, and I will put that onto the CD as well. Finally, here is the solution to getting all of those program outputs to appear within one version of more. The trick is, of course, to put them all inside parentheses and then pipe the results of the whole lot to the more program. Now I'll run that and prove that that worked, and there we go. It's given me the current date at the top, then the current working directory, then the contents of this directory, and then a list of users. Now I'll just scroll through that list of users, and then I get to the end. So more is allowing me to scroll through the whole lot, so that's clearly working. And to get them all happening all on the one line, which is another thing that I asked for, I simply do it using those semicolons. You can see there's a semicolon separating each of the commands right there. Okay, so those are all the exercises. How did you go? But we're not quite finished with this chapter yet, because I'm going to take a moment now to introduce to you the course project. And there are some exercises, or at least one big exercise if you like, associated with the course project. It's actually a meaningful, useful and somewhat substantial exercise, which will be more educational, more beneficial to you than these simple one-line, one-off, tiny little scripts that I'm getting you to do. Furthermore, there will be a couple of chapters later on in the course where the only exercises that I set for that chapter are exercises for the course project to enhance and expand the capabilities of the course project. So if you don't start the course project, then you will have trouble doing those course exercises later on in the course. Anyway, stay tuned, that's coming up next. So what is this course project that I've been talking about so far? Well, for the remainder of this course, we're actually going to develop this course project that I've been talking about. It is going to be an application. It's going to be a full-on application. It's going to be a few hundred lines of code by the time we're finished. So an application for tracking people's contact details, such as their name and address. So it's going to be a contact manager, or a very simple address book. Now, have no illusions. It will be a very rudimentary program. We're not doing this for the utility of the solution. We're doing this for the educational experience of writing a 300 or 400 line shell script. So, the features of this program, it will be menu based, it will be menu driven. So, by the time we're done, the user will start the program and they'll see a list of choices. What do you want to do? And they'll choose a particular option. They'll be able to create a new entry for our database, view the contents of the database, search for given entries in the database, and delete any contact details that match that criteria. and they'll be able to choose these options over and over again. They'll be able to maybe create 3 separate contacts, then view those contacts, then search for a contact, then create a couple more, and then maybe delete one before they finally quit the program, so they can keep going and going and going until they're done. All the details that they enter will get stored in a text file. So here is how I'd like you to actually start. I'm going to give you the specifications for this first phase of the project. I want the program to prompt the user for 6 pieces of data: their first name, their surname, their address, in other words their street address, like 10 Smith Street, then their city or suburb, then their state, and then their zip code. 6 pieces of data. Then I want the program to append this data to the end of a text file. If that text file doesn't exist, I guess the text file will have to get created. And I want all the data to be added on a single line in that text file, and every piece of information will be separated from the next one by a colon. So it'll go first name, colon, surname, colon, address, and finally up to state, colon, zip, and you don't need to put a colon after the zip. Then I want to ensure that the name of the file that you're storing all this information in, that the name of the file is stored in a variable, and I want that variable to be called fname, which is obviously short for file name. The actual name of the file itself can be something like names.dat or contacts.dat or something. It's up to you. But I want that to be stored in a variable called fname, and whenever you refer to that file, like whenever you write the data out to the file, I want you to write it out using that variable name. Now, you're going to have to figure out what that means, but you do have enough information to go about doing that. Then, before the program exits, I wanted to display the entire contents of the file, as well as, underneath that, a count of the number of records in the file. It can display both of those things, and then it can finish. Necessarily, the project will be fully commented. I want you to get into the habit of putting comments into your programs, so I want you to start straight away. Now, this will take some time, and it will take a bit of experimentation to get it right, but I really do strongly encourage you to make a good attempt at this. You may well understand everything I've explained to you so far in the 4 chapters of this course, but understanding something and then actually doing it are what I've found to be completely different things. I've watched many a student who claim that completely understood everything I've told them have absolutely mountains of trouble putting it into practice. So here is your opportunity to get some hands-on real-life practice in writing a useful shell script. I suggest strongly that you take it. Okay, good luck. I will meet you in the next module, where I will show you a worked sample solution that I've created for this particular project. Good luck. Well, how did you go with that? Let's go through my sample solution and I'll show you how I did it. There are, of course, no correct answers to this. If you did it significantly different to me, I don't really mind, just so long as you adhered to the specification from the last module. Here's my sample solution. I've called it Contacts. You'll find that on the CD in the Chapter 4 folder. It's actually in a subfolder of that called Course Project. Let's go through it line by line. Now we start with the first line, which is of course the shell interpreter. We're specifying that we want this script to be run every time using the Bourne shell. Now, of course, we put some little comments in to say why we've done exactly what we've done, a nice big heading as well for our script. Now, right at the top of the file, this is a good practice to get into, I've actually defined the name of the file that I'm going to be using to store my data. That means that at any time I can open up this script, have a look at the top of the file, and determine straight away that the file data is being stored in a file called names.dat. I can tell that because I've put a comment there to that effect. And down below I'm actually going to use that variable fname when I go to write out the data. Now the next bit is actually quite simple. It's just an echo and a read, and an echo and a read, and an echo and a read. I have made it all nicely right aligned here where the colons all line up with each other, but you don't have to do that, of course. And then we read all that information out, then we write the details to the text file. Now this is probably the most tricky line in the whole script. We echo this information out. We echo that variable, then a colon, then the second variable, then a colon, then the third variable, all 6 variables with colons in between each one. And I use the double greater than sign because I want to append to the end of the file. And remember that one of the features of the double greater than sign is that if the file does not exist, it gets created nevertheless. And what file am I writing to? Well, I'm writing to a file. It's not called fname. The name of the file is stored in the variable called fname. So what happens here is the shell reads this line and goes, there's a $sign there. That means that this bit here, fname, is the name of a variable that contains the name of the file that I'm going to write this information out to. So you'll find that this information actually gets written out to names.dat. Then we move along and show what's currently in the file. Now I'm going to do this as a grouping exercise here. I'm going to do 3 little echo statements. The echoes on lines by themselves are just for spacing purposes, just to make it look a little prettier on the screen. Here are the current contacts in the database, and then cat the file, and pipe all of that to more. I pipe it to more because there may actually be 300 contacts in the database if we run this program often enough. It's just a little precaution that's good to get into the habit of thinking of things like that. And then finally, we display how many there are. Now this I've done in a clever little way, I guess, using backwards quotes and a little blank line there just for neatness. There are, now I've catted the file and piped the results to WC-L. Now if you ran that on a line by itself, on a shell login line by itself, that would tell you just one thing. It would output a number, and that number would be the number of lines in the file called in this case $fname, which would be names.dat. Now because of the way we've structured our file, the number of lines in the file is exactly the same number as the number of contacts in the database, because there's 1 contact per line. So this will actually output a line like, there are 16 contacts in the database, hopefully. So that's it, that's the last line in the file. So let's run that and see if it works. Now I've made the script executable and I've called it contacts, so let's run contacts. Please enter the following contact details. Okay, Mark, Virtue, call it 12 Smith Street, Smithville, State, well I'm in Queensland at the moment, 1, 2, 3, 4. Here are the current contacts in the database, and then there's the names that I just typed in, separated by colons, which is very nice, and I've put little blank lines around it so it makes it easier to read. There are 1 contacts in the database. Now, while that may not be grammatically correct, it is indeed technically correct. So I can run it again. Let's just run it a second time, and this time it'll be Fred Jones. Oops. Oh well, I hope that turns out okay. Address 123 Hope Street, Hopeville. I'll put Hopeville in California. And now we have 2 contacts in the database. And the Jones surname did turn out okay. That #H sign was treated as a backspace. So mine was working. How about yours? You can go back obviously and have a look at the CD and open up my sample solution there, and you can copy and paste bits of my code into your solution if you want to. And that brings us to the end of chapter 4.